Hi, welcome to lesson 3.2, Characteristics of Polynomial Functions. Take a look at your worksheet there and examine all the definitions for polynomial, the degree, standard form, leading coefficient, and turning point, etc. So take a good look at those. Also, I'll just point out here that here's some examples of polynomials where notice that the degrees are whole number powers, 3, 2, and technically this would have x to the power 0, but we don't need that because obviously you know that equals 1. Again here, x to the power 4, 3, 2, x to the power 1, and then again this one would be x to the power 0, which we don't write. These are in descending powers of x, just like is seen here in the definition for standard form of a polynomial. Now, non-examples, take a look at these non-examples. Here we have x to the power 4, here's a squared, but now in this case, another way of writing this term would be 7 times x plus 3 to the negative 1. Okay, that's another way of writing this term right here. So as you can tell, that is not a whole number power, that's an integer, and so that is part of the non-examples group of expressions, non-examples of polynomials. And then also in this case, the second term, another way of writing that term would be 6x to the 1/2. Again, not a whole number power, so that would not be an example of a polynomial. And then in this case here, that's an exponential, and because the x is in the exponent, that's also a non-example of a polynomial. Okay. As we move along here, we've got general shapes of curves. Linear, you know, is degree 1, and the shape is a line. Quadratic is degree 2. It's a U-shaped parabola. Cubic is degree 3. It's like an S-shaped curve. Quartic is degree 4. U or W shaped, depending on how what the equation's like. And if you have anything 5 degree or degree 5 or more, they don't really have special names. They're just called polynomials of degree 5 or polynomial of degree 6, etc. Odd degree polynomials are S-shaped, but they may have extra bumps here and there, depending if it's degree 5 or 7 or 9. They're going to have a lot of bumps along the way. And even degree would be either U or W, or perhaps N or M shape, depending on the lead coefficient, with extra bumps along the way, like a degree 6 or degree 8 would have more bumps than would a degree 4. Okay, so let's take a look at some examples here. And what we want to do is we want to examine these things and really pay attention to the sign of the lead coefficient, the degree of the polynomial, the zeros, the turning points, and the end behavior. Okay, so we notice here that shape, obviously a parabola, so that means it's a quadratic, and obviously if we're multiplying two x's together, we're going to have an x squared. Okay, so the degree is going to be 2. And the sign of the lead coefficient, well, the lead coefficient would be anything that's in front of the highest degree. And it says right here, the coefficient of the term with the highest power of the variable. So we've got x plus 2 times x minus 1. If we were to expand that out, we'd get an x squared plus x minus 2. That x squared is the highest power, and the coefficient in front of the highest power in this case is a positive. Okay, so the lead coefficient is positive. And let's take a look at the zeros. We see here that there's 1 0 at x equals negative 2, and 1 0 at x equals positive 1. Notice how x equals negative 2 and this factor of x plus 2 kind of compare, and the 0 of x equals 1 and x minus 1, that factor, also compare. Okay, then we'll look at the end behavior. the turning points. There's a turning point here, so there's one turning point. Which is right there. And also with this lead coefficient, sorry, just to get back to that for a second, notice which way the parabola is opening. Okay, so it's opening up. And the end behavior, okay, so both ends basically go in the same direction. Okay, moving right along. Analyze this one here, please. Pause the video and analyze this one using the same technique. So pause right now. The sign of the lead coefficient. Okay, that's going to be a negative lead coefficient. Again, we've got two factors. We know it's a degree of 2 because it's a parabola. The zeros here, x equals -1, and here x equals 3. Notice how these compare, x minus 3, that factor, with x equals 3, that 0, and the 0 of x equals -1, and the factor of x plus 1. We have, with this negative lead coefficient, we notice also that the parabola is opening down. And we have one turning point. Which is right there. And also, because it's opening down, well, actually not because it's opening down, the ends are going in the same direction because it's degree 2. And they're going towards negative infinity because it's opening down. Moving right along here, degree 3, lead coefficient is positive. Notice that the general trend of the function is increasing from left to right. Whenever you follow along the function, you always go from left to right. So in this case, it is lead coefficient is positive. The function is increasing, generally increasing from left to right. Thus, the positive, where the positive will come in. The 0, x equals 0. Also, again, notice the factors. They're just x cubed. X equals 0 for the 0. We have to look at the turning points. Well, here there were no turning points. Okay, because they don't really, a turning point is where the graph changes from increasing to decreasing or decreasing to increasing. In this case, it doesn't change, like it sort of levels off a bit, but then it continues increasing. So there's no real change from increasing to decreasing. Because along here is not decreasing, it's just, it's sort of like horizontal. So there are no turning points in this case. And the end behavior, degree 3, the ends go in opposite directions. Alright, here we have, again, degree 3. Lead coefficient is negative. Now notice, because the lead coefficient is being negative, notice that as you follow along the curve from left to right, it's decreasing from left to right. I guess I could have said here for part C that it's increasing from left to right. And The zeros, x equals 0. Notice the factor there. And the 0, x equals 0. Turning points, again, no turning points. And the end behavior, because it's a degree 3, the ends go in opposite directions. Again here. Okay?